This episode will not really be about filming animals, but rather about how I got the idea to improve the quality of my videos. So I'm gonna tell about my customized trail camera created on basis of an old Samsung Galaxy S10. This video isn't exact instruction for repetition, but only a hint, an interesting idea that I implemented after spending a lot of time and efforts. I'm sick and tired of buying the same camera model and always getting different samples worse than the previous ones. Having once bought an expensive Browning trail camera, I was completely disappointed with its quality and had turned it back. And by the way, I haven't found any trail camera on the market with honest 4K at least at 30 FPS. Even among some Browning cameras, there are no ones capable of boasting 4K 60 FPS and autofocus. It sounds weird, but as a Galaxy S8 owner, I didn't even know about the brilliant feature of this phone, which had been covered for me for years. I knew about double click for camera wake up, but then I suddenly pressed the volume button instead of touch the screen and so video recording began. I never used that method before or maybe forgot it. The decisive criterion for making a game camera from a smartphone was the ability of the Galaxies, I don't know about others, to start shooting from the last mode that was used. That's interesting, I thought. So what about to tear down some of S10 examples and make control the buttons without pressing them? Let's try it by Arduino. The principle of operation is as follows. In premise, the regular trail camera detects movement and starts operating. Secondly, with the removed photodiode, it thinks that it's always night and sends voltage from inside to the infrared LED panel, which is disconnected. Thirdly, the received voltage is sent to the Arduino, then turns on and runs the code. Fourthly, the optocoupler module connected to the Arduino switches the contacts of the smartphone buttons according to the code. Fifthly, at the end of shooting, the power button is closed once and the screen turns off. Video saved successfully. To do this, I need a cheap trail camera. I use HC801, kinda Chinese no name. This one is taken from the forest and already painted. Samsung S series phone, S8, S9, S10, etc. And I'm gonna show in on 3 examples. They are similar. I bought used ones on the secondary market. Here the edges are a little bitten, the display with the black spot. All this doesn't affect the work. The most important thing is a surviving camera. It's cheaper to deal with damaged devices, but it's also too complicated and risky. The screen may be die during disassembly. This is the last time I do like that. Preferably to choose S10 due to the fact that it shoots in 4K at 60 FPS, better microphones, and the ability to record video in UHD being in maximum energy saving mode. Then we need cable glands, cables itself. I didn't use twisted pair, because the 2 power wires needed to be thicker. Battery holders, BMS with USB port, and Arduino. I use Nano because it's easily programmed in the field due to the presence of USB, a 2-channel optocoupler module, and a plastic waterproof box for battery pack, which capacity can be increased according to your preferences. I'm using Li-ion 26650 instead of the native built-in LiPo, and we'll talk about it later. Frankly, I couldn't create so-called deep sleep mode for Arduino, more efficient than a regular trail camera can. Yes, and the standard Arduino 3V output peer sensor doesn't satisfy me in sensitivity. It was decided that the wildlife camera would act as a motion sensor and a timer. Basically, it supplies voltage to the IR illumination only in the dark. And opposite, I need to make the camera turn on the light each time. So we tear down the camera, disconnect this PCB LED panel in order to get needed voltage to power the Arduino every time independently. We remove the photodiode. We find it among other indication LEDs and disorder it. I depicted the pinout of the contacts in the diagram. The next step is to cut off the tracks that power the LED strips. We found out where's the plus and where's the minuses by running a test video. After that, solder the wires to the plus and minus contacts and lay them neatly towards the drill hole in the bottom. Due to the very small space, it is impossible to install a cable gland here. I'm using a waterproof connector and epoxy glue. Then I drill 2 holes in a box to install the cable gland and push the end of this cable inside. After that, I will connect it to the VIN and GND pins on the Arduino. As I mentioned earlier, I don't know how to put the Arduino into deep sleep, so the code is quite primitive and looks like this. Assign Arduino outputs. Pin number 8 will be responsible for the power button and pin number 9 for the volume button. Knowing how the Arduino works, you can set any number. Next, we designate them as outputs and initially set them to a low level. Further, the algorithm repeats the virtual pressing of the smartphone buttons. The trail camera is capable of shooting up to 90 seconds maximum. So we will set the time for shooting a smartphone a little less, 85 thousandths, which is 85 seconds is enough, taking into account all the manipulations, turning on the screen, autofocusing, starting and stopping record a video, and possible bugs in the beginning. Just for example, I will write here 5 seconds. Download the code. Yes, I lose a few seconds at the beginning, where the animal can slip through, but I don't like those 2-second shots honestly. Well, now the hardest part, the teardown. We hit the edges of the phone with the hot air gun and carefully open it. Next, we get to the button contacts and solder thin varnished wires to them. They can be obtained from any relay coil. Then we need to make the transition to the thicker ones inside the phone. I remove the audio port and run 7 wires through it. 4 are the buttons, 2 are the power supply, they are thicker, and 1 is for the battery start. I'll explain it a bit later. There is a challenge to bring the 7-core wire out. It would be cool to remove the audio port and run it through, but the aluminium wall gets in the way. Well, let's try something. If your wire is a little thicker, then it doesn't matter, the headset input can be expanded by 1 mm. We push the wires through the removed audio port and fix them with the 2-component epoxy edges. It is also necessary to check the opening of the microphones, clean them from possible dirt before closing the back cover. What about power supply durability? It is known that phones are turned off at sub-zero temperatures. And this doesn't suit me, because I want to use the camera in winter. Okay, I personally made sure that the phone will work unstably by placing it in the freezer. After that, it was decided to remove the lithium polymer battery by cutting off its contacts from the built-in protection board. Later, I guessed to desolder the contacts and not cut them off. I replaced it with a lithium-ion battery and put it back in the freezer for 20 minutes. I pull it out and start the camera, everything works great without breaking. The voltage of the native battery is 4.4 volts, but the new external one is 4.2 volts. A little bit different, but isn't critical. It'll be displayed approximately 80% instead of 100. I fully compensate for this by increasing the capacity. But there is one caveat. Each time the battery is disconnected, the protection board is blocked. To solve this problem, it's necessary to short close once the minus contact on the battery with the common minus on the smartphone board. Further, I'll make a special button for this. And another important point, the smartphone will be able to adequately estimate the battery consumption due to its new too large capacity and slightly lower voltage. Setting the automatic restart once a day will solve this problem. The main condition for auto restart is the presence of a SIM card. You can use any old SIM card even with zero balance. The Arduino having turned on, gonna start executing the downloaded code, switching the buttons of the phone by sending commands to the optocoupler module. Please note, if the button wires are not connected properly, the sequence of actions will be violated. After messing with wires, we mount the Arduino and optocouplers inside the box. The galvanic isolation of the optocoupler allows the use of different voltages, 8 volts for the trail camera and 4 volts for the smartphone. Jumpers need to be removed to separate GND. Next, we make a reliable module for Arduino with screw terminals and the BMS reset button. The arrangement of the elements provides access to the USB port and doesn't interfere with closing the door of the box. Then we organize cable management. This will make future upgrades and repairs easier. I won't go into details about this, because you can do it to your taste. The next step is to assemble the battery holders for parallel connection. In this case, 4.2 volts. We insert all the batteries strictly observing the polarity. I already soldered a quick release connector and left that behind the scenes. It is universal and suitable for powering the smartphone and charging the battery pack itself. Finally, the long painstaking work is done. Let's move on to the next stage. Since our phone has lost its firmware impermeability, it's necessary to put on a double-sided silicone case on it, glue all the holes around with B7000 adhesive and insert waterproof plug for USB ports just in case to prevent moisture getting inside, insects, spiders, etc. We hide the wires as the most vulnerable part in the metal sleeve. Little busters love to chew on these things. I got tired of them in the camp, but never mind. Even though the device became waterproof again, the microphones and lens are susceptible to flooding. The sound and picture will be corrupted for a while, until it dries. So there must be some kind of roof over the phone anti-precipitation. I will make it from piece of cable raceway plastic. We place the smartphone in a special rig so as not to cover the microphones on the sides. Paint it in khaki and tightly fix the cable with clamps. The camouflage will be made of painted fabric with glued artificial bark elements, like I do it with other cameras to prevent them being detected or stolen. But how can this camera be able to shoot in the dark? No how without additional daylight. And for the smartphone I have a special solution, and this is a topic for our next video. I'll just show you briefly. Having disassembled the headlamps, I removed the drivers from them and routed the wires through the cable glands. Frankly, I'm bored with black and white videos, and just for this occasion, the smartphone will be provided with a synchronized LED lighting system with a smooth start and finish, so as not to scare the animals. No matter how waterproof the flashlight is, sooner or later water will seep inside and ruin the electronics. Therefore, it's necessary to make camouflage canopies from direct precipitation. There is a temptation to increase the brightness of the lights, but this shouldn't be done. The best you can count on when shooting at night is close-up portraits of animals. Here the camera does a pretty good job in autofocus. Therefore, I abandoned the idea of a very convenient location of the lights under the rig and moved the lighting a little to the side. As practice has shown, they are not particularly afraid of artificial daylight, although they are sometimes wary of unusual effects, but that doesn't stop them from meeting all the treats. And this calf apparently seeing its own shadow for the first time. Well, I know this has been a very long message, so that's all for now. If you have any questions, feel free to ask me in the comments, and the information was useful, please like this video. See you.